Controlled rock blasting. The demand for tunneling and underground space creation is exponentially growing due to civil infrastructure projects and urbanization. The use of explosives for rock excavation is necessary in most mining and construction industries. This technique is known as rock blasting. Blasting is one of the most economic methods for hard rock fragmentation. However, it is a highly destructive process that can cause major ground problems. It is important to evaluate the factors influencing rock damage. The cost and safety of blasting damage is a crucial consideration in the process of the method. Techniques to control blasting impacts have developed over time. With the use of controlled blasting, excavation can be done around vertical and horizontal corners and result in accurate lines. Controlled blasting can also improve the appearance of rock slopes. The method of blasting consists of drilling holes at a center depth, diameter, and spacing in order to control the breakage of rock. Understanding the physical dimensions is important to understand the design of a controlled blast. The burden, B, is the distance between the free face and the first hole. T is called the stemming, which is the inert material in the hole. The length of the bench height, L, and the blast hole depth, H, are also important design considerations. Oftentimes, excessive breakage of rock occurs in blasting events, which is known as overbreak. Overbreak and fracturing are the major issues with the methodology of blasting. There are two main types of overbreak that occur during the process of blasting: backbreak and endbreak. If there is an excessive burden on the holes, the explosive can break rock that is beyond the last row of holes. Backbreak will most likely occur if the bench is too stiff. This means the length-width ratio is less than 2. Backbreak can also occur because of excessive burden or if the timing of blasting from row to row is too short. The main cause of endbreak is local geologic structures that can cause extension of cracks on the ends. Using controlled blasting methods, such as pre-splitting, trim blasting, smooth wall blasting, and line drilling, rock damage can be eliminated. Pre-splitting is one of the oldest and most commonly used rock excavation methods. Pre-splitting is a technique used to construct a clean sheared fracture plane that allows for steeper slopes. The procedure consists of instantaneously firing a group of closely spaced holes surrounding the main blast that is desired. It is important that the charges are set off simultaneously or as close as possible to cause the adjoining blast holes to collide, which causes the formation of tension cracks. The holes are connected by the cracks that separate the main blast from the surrounding rock's walls, which are left undamaged. Trim blasts are designed similar to pre-split blast, yet they are fired after the production round has been fired. The spacing between the blast holes are usually larger than pre-split blast holes. Unlike pre-splitting, there are burdens present since the production round has been fired. It is important to take the burdens into consideration for the design of a trim blast. The burden is designed to be approximately 1.3 times larger than the spacing to ensure that the fractures link properly between the holes. This technique is simple and economic compared to other methods. Another method is smooth wall blasting. The purpose of smooth blasting is to control the distribution of the loads and the release of shockwave energy. The hole alignment and spacing is critical, similar to all other methods. The hole spacing should not be greater than 0.7 times the burden. Unlike trim blasting, the decoupled holes are not filled with loose, crushed stone. Normal blasting sequence occurs with smooth blasting, with the excavation row being last to fire. Smooth wall blasting effectively reduces excessive hole crushing. Line drilling is sometimes utilized in pre-split and trim blast holes to help guide cracks into a specific angle. This method consists of placing rows of unloaded drill holes along the excavation line. The spacing should be no greater than twice the size of the hole diameter. It is sometimes necessary to use line drilling before pre-splitting where there are 90-degree corners present or with structures that are adjacent to an excavation, because pre-splitting may cause excessive wall damage. The disadvantage of this system is high drilling cost, and results are often unsatisfactory because of poor hole alignment. These controlled blasting techniques reduce ground vibrations, air blast, fly rock, and other environmental effects. When an explosive is fired in a blast hole, it forms a seismic wave to travel through the rock on the blast site, causing blast vibration energy. High levels of vibration near the blast holes can cause fractures in blocks of rocks and extend the existing fractures. The vibrations from the blasting can generate fly rock. Fly rock are rocks that are propelled into the air from blasting. Every blasting event is expected to have some fly rock, but it is important for it to be controlled. Fly rock can travel distances greater than 1 kilometer if not controlled. It is also important to consider reducing the effects of blasting on nearby residents, such as loud noise levels known as air blast. Air blast can actually crack walls and break windows if blasting isn't controlled. This occurs when the pressure of the sound wave is sufficient, which is known as overpressure. In conclusion, the selection of which blasting method to use depends on the project specifications. The techniques can be used singly or in combination in order to improve results. These techniques are essential to ensure sound and long-lasting excavations. Blasting remains the most satisfactory technique for excavation of rocks. Over time, blasting methods have been developing in order to optimize results. The continuation of the advancement of these methods is important to improve overall environmental and safety standards.